In this video, I'll demo the conversation engine and a particular portion of the conversation engine. I'll show you how we use a behavioral intent language to define some of the requirements. The value of this is to get some very rapid iteration, sort of minute-long iterations that are meaningful, where the business is able to come up with new ideas, trying to break the requirements as you have, and we'll refine, we'll create some executable software, they'll run it, they'll find some issues, we'll fix it, we create more executable software and so on. Extremely intense sessions, typically lasting somewhere over a few hours, maybe sort of half a day, in some cases several days, but more typical is a few hours. We actually have several of these languages. I will only demo one of them, sort of the behavioral collaboration language. Another very important language for us is sort of the data or the domain modeling language, but I'll keep that out of this particular demo. What I'll do is I'll create a very simplistic version of something called price negotiation that is happening between hospitals, their suppliers, and their distributors. What is important for us is to identify who are the players in that field. So this is part of our requirements gathering. And the players here are the hospital, the supplier, the distributor. And the hospital really plays the role of a purchaser. Just to draw this up somewhat contextual, let's say we have a hospital, and inside the hospital is some person that plays the role of the purchaser. Another actor in this space would be the supplier, the ones that produces whatever the hospital buys. And finally, we have the distributor that takes the product from the supplier and delivers it to the hospital, say an MRI machine or something like that. Now, assuming we're going to build a system to help facilitate this, we need to define who these actors are and how they collaborate, in what order things are supposed to happen. Now, let's say the conversation between these actors goes something like this. First, the purchaser asking the supplier if they can get a special kind of price. The supplier will respond to the purchaser saying, "Here is my suggested price." The purchaser can accept this price, and then finally we have to inform the distributor that we have agreed upon that price, so they will honor that price as they take the MRI machine to the hospital. And finally then, a purchaser can buy off the distributor the MRI machine for the price agreed upon. Now, this may be something that someone drew up on the whiteboard just to give us some kind of context before we start running our requirements sessions. But what we need to do is to formalize these requirements and make sure that everyone agrees upon them and that everyone understands it. At SciSpark, we developed a specific tool for that. And that tool has a language, an intent language that we have to follow. And the way we do it is we try to identify what all the actors are, and we build what we call a state machine for each one of those actors to describe their behavior. We call this collaborative behavior, this interaction between the actors, for conversations. We didn't call them business flow or anything like this because these words have been used, and we're using a language that's quite different. One that leans itself, I think, to more isolated discussions, so you can focus on things, but it actually also turns out to be a really good implementation model. I call them actors here in honor of Carl Hewitt and his model around actors. You will see I'm actually going to call them agents in my language. So in what we see here is we have three agents, the purchaser, supplier, and the distributor. That makes up and there is a flow of messages that has to happen, and that together makes up a conversation. I'm going to flip into Eclipse or into my virtual machine and start developing this for you. It's going to be textual, but it's good to have this as a context while we're doing it. I'm now in my virtual machine, and I've set up a virtual machine to make it easier for me to develop. Anyway, what I'm going to do is I'm going to create a brand new project from scratch. Imagine I'm going into this requires gathering meeting, and the first thing I will do is to create a new project. We created a command line tool for that purpose, so all I need to write is conversation create pricing, which will create the project. What this tool does is it sets up a project template with all the open source modules that we're using and some default setup of a project. It's very similar to what you might have seen in Maven, for instance, with the Maven archetype. I'm actually going to do my editing in an IDE, but it was very important for us that you should be able to build these conversations without actually having to depend on an IDE. So you can use your VI, Emacs, Sublime, whatever is your favorite text editor to do everything. That's actually not that important for this demo, but if we now go into this directory, what we'll see, if we created a whole set of files that I'm going to use for development. We developed some special editors to make it easier to audit these intent languages. So I'm going to flip over to Eclipse and import this directory that I created into Eclipse so that we can start editing it. Okay, looks like we're all set. What I've basically done is create that directory, or use this tool to create the project, and then I've imported it into Eclipse. Eclipse knows that it's a node project and I'm able to play around with it. The intent language that I'm going to show you, the one language I'm going to show you, is in what we call CL file for conversation language files. And by default, when I did the create, it created a very simple file that I'm just going to gut and fix and build up the specification for the example that we saw the context for. First time we're going to create a type called price negotiation. This is just an object that's going to tie the agents together. Next, I'm going to specify that we have an agent called buyer that is concerned about the price negotiation. We need to define its state machine or state behavior. And we have a textual way of doing that. I'm going to say it initially becomes ready, ready being a state, and it has another state called waiting for response from supplier. Two states of the buyer. What makes it go from ready to waiting for response from supplier is an event that occurs internally that we're going to call request price. And the behavior is such that if a buyer is in the ready state and it receives request price, it becomes waiting for response from supplier. State machines are often shown graphically, and we always generate a graphical rendition of the state machine along with the textual file. Although some domain experts are able to verify things directly off the diagram, it's actually quite difficult for someone that is, say, a doctor or someone that is an expert on purchasing to understand some of the notations that we have in computer science. So although these diagrams can be quite useful, they're not the only answer. Just to make sure that you follow me, let's go back to the drawing and take a look at it. So what we're actually doing now is I'm building a state model in text for the intent or the behavior of this actor purchaser that we saw in the context diagram. And so far we gave it a couple of states and one transition. Of course, we need to also define the other agents and their behavior and how these agents interact with each other. Okay, let's get with it and create another agent. This time I'm going to create the supplier, which is concerning the same price negotiation. When I'm defining the state model for the supplier, I realized that the supplier role really only comes into play when the buyer sends out the price request. So what we have to do is to add a few things. I need to set up on the buyer that it sends a price request, and I'm going to specify that the supplier comes into play when it receives that price request from the buyer. The supplier will go into the state evaluating buyer. So I need to set up that state and then say that the event causes it to go into evaluating buyer state. What's interesting here is that we've now seen an example of a collaboration between two agents. The buyer will send a price request that causes the supplier to come into play and then go into the evaluating buyer state. When the supplier is in the evaluating buyer state, it has to decide whether it's going to accept the buyer. So it has to privately receive, as we call it, accept buyer. Think of this definition as if it decides to accept the buyer, it becomes, say, finished, and we need to define the state finished. When it makes the decision that it wants to accept the buyer, it obviously has to communicate that. So it has to send out a message, say, buyer accepted, and then we have to make sure that on on the change of state when it receives accept buyer, that is when we decide that we accept the buyer, that it also sends out that message. Now let's take a look at the diagram and go back to the graphical visualization. And for someone that is used to reading these diagrams, they can immediately see that there is something wrong with this diagram. I see that when a supplier is in the state evaluating buyer, it produces the event supplier buyer accepted. But what's the problem is that there is no one that is actually listening to that event. And that gives me a graphical indication that something is wrong. And at SciSpike, we have people that are very experienced in this notation, so they would immediately detect that and fix it. So we would go back to Eclipse and take a look at who's going to listen to that event. And in this case, it is the buyer that needs to listen. And so we need to add, while we're waiting for a response from supplier, we need to say that we received the supplier buyer accepted and become, say, finished, and add that state. And we can now flip back to the graphical view of this textual file, and we can now see that it looks better. The buyer price request is being consumed by someone, and so is the supplier buyer accepted. So that shows us how we can use the models or the graphical depiction to discover errors. This is not the most common way of discovering errors, though. So even though we've gone through now a few iterations and we've been able to find some issues and fix them and so on, that's normal. This is something that pretty much anyone that is fluent in modeling can do. What we're going to see next is how we can actually take a look at this through execution. And this is when the domain experts tend to be much more active and engaged. So now I'm going to flip back to the command line, and I'm going to run a command line tool that we call conversation play, and this is for playing with the specification. You might be curious what conversation play does. What it really does is it starts up a set of processes that are listening to changes in the file system, and if there are certain changes, it analyzes those changes and it decides what to restart or regenerate. So if I change something in this conversation file, it will basically regenerate the code, restart the server, regenerate documentation, and so on. What is important now is that I have a running server that allows me to execute the conversation and play with it. And by opening a browser on a particular URL, I can now start playing with the specification. The browser is now rendering both of the state machine, and it also has a way for me to stimulate each one of the agents. Now, this is quite technical and is typically used by someone that are very fluent in the conversation language, but it goes to show at least that we can simulate and see all the agents working together. I made the screen a little bit smaller so we can see both agents at the same time. But if I now click on this button that simulates the buyer requesting a price from a supplier, we will now see that the state machines are changing, and we can execute through this business flow and ensuring that we have all the states we need and that we can get to completions and so on. So if I click on request price, we see that the agent buyer goes to waiting for supplier, and that the supplier comes into place, not in evaluating buyer. And then if I click on accept buyer, then they both go to finish, as we had specified in the textual language. Now this is very useful for someone, as I said, that is very technical. Some of our domain experts learn to appreciate this, where you can see all the agents together. But most of them really want to play one agent at a time. So let's play one agent at a time. If I go to another URL, we would get sort of to the home screen, where we see that there are a couple of tabs, one for supplier of pricing and one for buyer of pricing. This screen allows me to play each one of those roles. We basically generate a user interface that is kind of wizard-like, that allows us to play one of the roles in this conversation. We typically let each one of the participants play one of these roles, but for this demo, I'm going to try to set up a few windows with the browser so we can see both the supplier and the buyer on the same screen. I'll simply fast forward through some of this movement of screens, but basically all I'm doing is setting up two different browser windows, one playing the supplier, one playing the buyer. But as I said, in most cases, the participant would play these roles and they would have their own devices. I'm going to create a new conversation I'm just going to call 111, and we'll have the supplier on the left and the buyer on the right. And we can now start the execution. And let's say the buyer decides to request a price. And maybe already here a domain expert would go, oh, wait a second. When we request price, we need to know who they are and what their budget are, what their budget will be. And immediately we find a problem in the specification and we need to go and fix it. But the nice thing now that everything is up and running is I can go back and just simply change the specification and then just refresh these pages and everything will look the way they want to. So along with the event request price, there is some data that has to be passed, and we can define that as types in the conversation language. There are some much more sophisticated stuff we can do, but I'm just going to stick to the simple thing here. And create a type that I'm going to call price request. And I say we need to provide a name of a hospital and the expected purchase amount. Next, I need to attach this data structure to the events. Basically, what I'm going to say is that when we send out the price request, we have to have this data structure coming along with it. And also that obviously has to be generated when the buyer creates the price request in the first place. So now we can go back to the browser and simply just refresh it and then go to the same conversation. And we'll see that now that when you request price, that data structure is required. But notice the speed of that iteration. It took maybe a minute or so. I was able to introduce the data structure. They can discuss it back and forth, get it right, and then we continue where we left off in the conversation. So we'll enter some data, submit it, and then I need to refresh the supplier side here also so we can join the same conversation. And we can now see that the supplier is in the state of accepting the buyer. And perhaps at this point, the supplier expert in the room is saying, oh, well, hey, you can't just accept the buyer. You need to tell them what price and what contract they're going on. And we'll go back to Eclipse and fix that. Now, that would be a very similar change to the one that we saw before. We'll have to go and create some data structure, let's say price contract suggestion that has a name of a contract and some price, again defined as a data type here. And I have to specify how that data type is related to the event. In other words, which event's carrying that data structure. Perhaps at this point, someone points out that the buyer accepted is not a good name. We really should call it something like price contract suggestion. And notice that the language editor here supports things like refactoring of such events and so on. But the nice thing about this is this change of name is happening while we're discussing intent and not while we're down in the weeds writing Java, C# or C++ code. But while we're still doing intent, while we're actually there with the domain experts. Now I'll shorten some of these steps, and perhaps we're running again and we're looking at the scenario and someone points out that, you know, when we supplier does a price contract suggestion, it doesn't actually finish. It goes to evaluating the price contract. So the buyer should now be in evaluating the price contract, so we'll fix that. And while we're at it, the buyer then has to either accept or reject the price, so we need to privately receive these two events. Now, while we're in evaluate price contract, we can now say that either they accept or they reject. If they accept, they become contracted. If they reject, they become canceled, say. Now, notice that this could have taken many iterations with running in front of the domain expert. But in this case, I'll just fast forward a little bit. Now, perhaps we want to go back and look at the diagram and study the diagram. And perhaps we see here that there is nothing being sent out from the evaluate price contract when we go to contracted and cancel. And we may detect already at the diagram level that something is missing. And we can do another iteration. In this case, we'll add the two messages sent from the buyer, price accepted and price request canceled. And we have to make sure that these messages are sent when the buyer accepts or rejects the price request from or price suggestion from the supplier. And while we're at it, we can make sure that the supplier receives the messages that we're sending from the buyer. So the finished isn't quite right, so we refactor that and call it waiting for supply or waiting for buyer. And then we'll listen to the buyer price accepted and say that that should become contracted. So we need to add that state, and then we receive the canceled print price request canceled, and we need to add that state and then make sure we become canceled. Now we can go back to the diagram and take a look. And what you'll see is that these diagrams are now becoming very complex and hard to understand. And you can imagine if you're a domain expert and you have to evaluate this diagram, and the developers are hanging over you saying, is this correct? Is this the right flow? It's very difficult to commit to that. And this is why we often see domain experts and business analysts being very hesitant to commit, because they can't see it. And honestly, as diagrams get complex and flows get complex, it's difficult for programmers even to read this. So what we want is not to have to commit to a requirement at this level. We need to see it running. And of course, in many cases, even in Agile development, you may have to wait weeks until you see it running. And only then do you see, this doesn't make any sense. But we need to fix that. This is not a problem for us because we can always execute the specification. We can always play through scenarios. So if we go back to the browser, we will see that all these changes have already happened. So as we go back, we can now click on Accept Buyer. We see now that there is a name for the contract. There is some price that we have to send. All the changes to the data structure that the domain expert found originally is now working. And as we submit, if we go back to the buyer, we see now we can accept and we can reject the things that they wanted to do. Let's say we accepted, and now you can see both the buyer is contracted and the supplier is contracted. And we can play through as many scenarios as we want to make sure we got it right. Well, just to complete the example, let's go back and also define the last one of the agents, the distributor. So the distributor is an agent concerning the price negotiation. It initially receives the buyer price accepted event. Now notice this is actually a broadcasting event, because the buyer price accepted is actually listened to by both the supplier and the distributor. And this is actually why we don't call it an active framework but an agent framework, because we've done these kind of modifications. I'll just continue to define this distributor real quick. So it initially becomes processing contract. Processing contract is a state, and privately it receives contract process. That means the distributor decides that the contract has been processed. They're ready to handle that contract or for that price. So when they receive that, they become completed, and that's the end of the distributor's job. Well, I guess the buyer would eagerly await the contract to be processed by the distributor, so we probably should distribute that event. So we say we send the contract available for purchase and make sure we send that before we become completed. I'll also update the buyer so that instead of being completed, it's waiting for the distributor, and when it receives the distributor contract available for purchase, it becomes contracted, and that will be its end state. And if you weren't convinced that the diagrams are too complex to evaluate before, if you now take a look at the diagram, notice how hard it is to evaluate this diagram. It's a lot easier for domain experts to evaluate it by executing scenarios on running software. So let's try that instead. Now I need 3 windows. I need to refresh the supplier and the buyer, put them up on the same conversation 111, but I also need to introduce a new page for the distributor. Just give me a few seconds to set that up. Okay, I think we're set up. I have the supplier on the top left, distributor on the bottom left, and I have the buyer to the right. And I should now be able to play through a whole scenario. So we'll start by requesting a price. We had the hospital, my hospital, the expected purchase amount, some number. When I submit that in the supplier window, I can accept the buyer. We had some data for that, the name of the contract, the price that we're going to give them on the MRI machine or whatever. And then we submit that, and we now see that the buyer can accept. And notice when I did accept, both the supplier and the distributor changed state. And now finally the distributor say we're complete, and every one of the agents have come to an end state. Now, as I said, typically everyone would have done this exercise on their own machine, playing one of the roles, but we can also go back to the diagram that was slightly more technical and connect to all of the agents at the same time and see the state machines and how they change. As I request the price, we go into waiting for response from supplier. There's a data structure that I can play around with there too. And of course, the next step is that the supplier accepts the buyer. And when they accept it, they go to waiting for buyer. And now the buyer accept the change to the contract or the price of the contract. And then the distributor says that the contract has been processed, and every one of the agents have come to the end state in that sort of combined view. The way we run these requirements sessions is that we typically have some kind of conference room that has a table and a projector, at least one projector. And then on the main projector, we will project that combined view that shows the state model, so we can monitor the conversation that we're discussing and see all the states at one point in time. The next thing is that we have one person, typically one from SciSpike, although there are some of our customers that actually have achieved fluency in the language. It's not that hard to do, so if you're doing a lot of requirements, that's obviously a good way of going. So we would have someone that basically write the intent language, call it the intent language author. And they will project whatever they're doing onto the main screen. And then we will have these domain experts. So say, for instance, we could have someone that is an expert from the distributor part of the world, one that is an expert from the supplier, and maybe one that is an expert from the buyer, and so on. And another important role is that of a product owner. Now, each one of the expert that's going to play along with us will have some kind of device, typically just wirelessly hooked up to the one with the intent language, and then they play each one of the roles. I had to create a separate window, and it looked kind of weird for each one of the actors or the agents. But imagine that each one of these will play one of the roles. And this is extremely efficient because each one of them will try to break the specification you have or come up with new ideas. Like say, oh, well, in this scenario, these things can happen, and so on. And when there is a conflict, I need the product owner to basically step in and say, no, we're not going to do it that way. We're going to do this for phase 1 and this for phase 2 and so on. But extremely efficient. And as you've seen, even in this little presentation, I probably did 10 iterations. Small iterations, small changes that I had to do to fix different things. And I skipped ahead a little bit on some sections that would probably have required several iterations to get to. So the end result of these sessions and these tooling is that we get these iterations that are measured in minutes. This allows us to have many course corrections, and some of those course corrections could have taken weeks or months to found in a more traditional requirements gathering. Another thing is that the domain experts now can be put in one room, and it will be very efficient. You don't have to get the domain experts together at regular intervals, which is often very, very difficult to do. It's fun, and while the people are trying to break the systems, the discussion is always very relevant, and it's at the right level of abstraction. Another good thing about this approach is the documentation we leave behind. Now, we did take a look at some of the diagrams while I was playing around with the specs, but I also want to point out that we generate documentation, proper documentation. So from the intent language, we make a natural language description of the specification itself. This natural language specification can be produced in many forms. It could be produced in PDF or in ebooks and a few other formats. But in this case, I'll show it to you in HTML. So all the time while we were generating the application and the diagrams and so on, the tooling would also generate a HTML website that has the documentation. And that documentation consists of the diagrams, text that is trying to explain the state machines in natural language. And those are sort of an index site. We're using a tool called AsciiDoc to produce them. And it's a very, very powerful set of notes that the participants can take with them and use to maybe review it further or take it back to discuss with other participants or other domain experts. The intent languages that we have support markup, so anything you put in a multi-line comment will be extracted and put into this offline documentation. And it supports the full markup of AsciiDoc, so that you can put in things like, for instance, bullets and so on. And you see, as soon as I save this and go back to my browser, that content that I put in the top of the file will be available in the HTML documentation. So the advantage of this whole approach is we get really accurate and efficient requirement gathering. And it comes from the participant being able to play with the requirements, sort of the gamification of the whole idea, which you can do in other forms also, drawing sketches. I've seen people using tools like Balsamiq very efficiently, although there's nothing like real running software, I feel. The corrections and alternatives that come up can be developed in seconds, as you saw, and the requirements are defined as intent at the proper level of abstraction, because we're using this intent language, because we can execute through the specification. Both developers and the business people tend to come to a common understanding. And it's precise while it's still abstract, which is also a big advantage. Well then, all that's left for me is to thank you for listening to this presentation, and please contact us if you want a more thorough demo of what I've shown you, or if you're interested in some of the tooling that we have.